Hello, welcome back to the next session, LINX119. We've got a remote presentation that's about to start now. We've got a guest IXP. We always like to hear from our guest exchanges. And Vladislav Bidikov from the Faculty of Computer Science and Engineering from IXP.mk, that's in Macedonia, is going to do a presentation. DDoS attacks, how small networks can defend themselves. So if I'd like to hand over to Vladislav now, I can see he's on screen. Thank you.
Okay, so hello everyone. Nice to virtually see you there. My name is Vladislav Bidikov, and in the next 15 minutes to 20 minutes, I'll try to show you interesting usage of IXP.mk initiative, which is under the Faculty of Computer Science and Engineering. So first, in order to get the picture of why we are having small in the title of the presentation, we need to understand some things about the size of the Faculty of Computer Science and the university. So we actually run our own data center, one for the faculty and one for the university. We also run the local IXP.mk, which officially is the name of a project here called High Ability Internet Connection and Research Platform, in parentheses testbed. And we have a lot of students in the faculty, more than 5,000 students. And most of our systems are electronically first. That means that at the end, when they have to get a diploma, eventually they have to bring in some paper into the story, but generally most of everything is done electronically. The size of the network, which is important for you here at the presentation, is that the university announces 1/19, usually a /24 for each faculty. It has internet access from the giant network. It has local peering to the IXP with 10 gigabits. And there is a backup internet from the faculty, somehow like a connected island, although this backup is a cold backup one. So that means that engineers have to arrange on when do they activate. And the university itself is hosting a very limited set of e-services, mainly because over the years, because of people leaving the university computer center, most of those services are now moved to our data center. On the other side, the faculty announces 4/24s out of the university network, /19, and additionally 4/24s, which the university got in the end of the IPv4 just before the depletion. Our internet access is one 10 gigabit link from the university, which is out of the 2 × 10 from the giant, 1 gigabit from a commercial operator 1, and 1 10 gigabit from a commercial operator 2. I have to mention that the second line was not active when this was happening last year. We also have additional 10 gigabit peering to the IXP. We host a lot of university-wide system, which is the central student record system, the admission system, the university learning management system, and also we host our own services, which is our own learning management system. Just to refresh you, this was happening still in COVID times, where we also had active a video platform, which we used locally. And of course, the standard CCTLD things, as well as the National Health System and the Ministry of Educational Systems. The last system is also important because it was used to provision teams for all the primary and secondary schools in the country while they were online. About attack history, because we have a lot of IP space and different user types. We have faculty, students, governmental users, research. Attacks are usually daily, weekly, and usually are handled, I would say, a bit semi-automatically. It's bans on the firewall detected by the IPS or a manual knock intervention. We also have capabilities to use the DDoS protection, which comes from the internet access coming from the giant network, only for that uplink. In the last 10 plus years, we had nothing serious. Generally, we always say we as a faculty are not interesting target. So this will not happen to us as a faculty, although because we host other systems, we tend to saw attacks on the other systems. And this will change in June and July 2022, when 2 sets of attacks happen in similar time and size. we were still in COVID time, so exams were going to start. The semester was ending. The first set of attacks were just in this period, and we saw that the target is actually the learning management system based on Moodle, which is used to end the semester while we prepare for the exams. Also, the official website of the faculty was attacked several times a day just at the end of the semester. We were expecting an exam week, and this continued in the second attack. This is the first time we actually felt something. It was generally volumetric, UDP based, and it was lasting between 30 and 59 minutes. Network starts to break, but not because the attack was big, because we saw that actually this 10 gigabit link, which was between us and the university and then to the Ender and Marnet, was actually getting filled up because of a physical reason. It was stuck to a 1 gigabit line, and we had to actually do a simple cleaning of the fiber to get this on row. The faculty computer center where I work decides to make some network changes in order to make most of the services for exams to be available only via the IXP. And with this moment, to also verify if the faculty itself is the target, and or maybe some of the other users on the IP address space. We also saw the need to really improve visibility in order to locate problems like this, like the broken fiber on 1 gig, faster. On August 2022, in the boost of the exams, things get a bit more complicated. We see more things attacked. We see longer attacks, purely volumetric. Exams are still online, and it was expected to be online. And you see attacks are getting now up to longer periods. And we decide, because network starts to break and having attacks lasting 30 to 120 minutes, we enter what we call panic mode. And we have, because we have a lot of IP space, we tend to move or make access to the system to be exclusively via the IXP. In the same time, the network system engineering center is actually improving visibility based on NetFlow. We installed what we already had. We got a free license from FastNetMon. We got Giant Operating Center on board. We limited outside traffic. But what we have seen is actually that traffic levels are doubled every attack. So I would say every day. And daily, there were several attacks. This is why we ask for traffic coming from the Giant network, or in our case, the big internet, that we switch DDoS protection mode to always on mode, which means that all traffic will be cleaned. But in the same time, our freshly installed NetFlow monitoring tools show us that actually attacks are starting to develop, and actually it's not longer just UDP volumetric. As you can see from the screenshot, tends to be a bit of a different protocol subset, creating even more havoc. In the same time, we hear some interesting rumors that the attacks on the system may be connected to some student involvement. We were not able at that time to verify this, but in order to see if this is possible and plausible, we decide to move all essential services from the faculty to a fresh /24, for which we already had rebuilt the NetFlow and baseline services. So we will have a clean vision and possibility to analyze what is happening. And this creates the first reaction from the hackers, which actually they started to hit us pretty hard. As you can see on the graph, we see attacks in the volumetric level of 50 gigabits per second. We start a very interesting cat and mouse game. First, what we did is we created direct links for NetFlow and core router, for NetFlow from the core routers for analysis. We also decided to drop non-needed traffic on the giant routers we are connected to in Sofia and Vienna. And this is where we actually pressure the hackers to attack a new target. And this is the student enrollment system for the university. What we see as a problem at this moment, and because that week is the week when they apply for university, and if this cannot be moved, although it's an electronic system for many years, the law forbids us to move around the dates. They're strict. So this creates a big problem for the university itself, and we get some negative feedback from other faculties which have less students. At the same time, they start to really pressure us and see how equipment will hold, because we actually see that they start to carpet bomb the whole IP address range. The problem is that for our range, for the faculty range, we had some protection in place, but for the rest of the /19 from the other faculties, they were just not ready for this. And each of these attacks is actually completely breaking the university network. And from the visibility we had with the NetFlow, we actually see a really large botnet in place. And some screenshots from command and control servers actually are showing now that this student involvement is partially plausible or possible. You can see here on the screen the type of attack which was evolving. They also decided that since we use some of the routers were Cisco brand, they actually started to, and they were patched, they started to use well-known exploits on exhausting CPU or RAM resources. This is, we now switch the story. We say, okay, this is now important. There is a big botnet who can do a big harm in the community, especially in our fragile.mk industry domain where uplink is limited. So we say we're going to switch the story and we're going to start to collect as much of data about the machines attacking us, but in the same time, make sure that services are available. We do another switch and we actually move all our important services to a new fresh /24, which was available only via the IXP.mk fabric. So, and since it's COVID times, remember, all our students, professors, and users are in MK, and all operators have direct connection to the IXP and have peering with us. This will be a very good idea. From the inside, we are completely online. For the outside world, the targets which are attacked are offline. Their reception is done and completed. Hackers think that they did their job. In the same time, on the routers, we started to create advanced rules that will stop the volumetric attacks, mainly connected to UDP ports 53, 80, and 123 at Giant, but still try to monitor. And we start to see some more advanced TCP flooding. You can see here on the graphs the amount of dropped packets on the routers on the bottom graph, and the set of advanced attacks which are now a bit lower. You can see around 34 gigs, which managed still to pass our defense. And then something very interesting happens. Although sites are not accessible and they are via the IXP, they start to really hit us hard with a new protocol. So the memcache UDP exploit enters the arena. We are still collecting data, but we actually see a large amount of servers, real servers in cloud providers, who are actually passing through the whole thing and again attacking. You can see on the bottom screen that they're completely filling up the link on the blue lines with memcache data, and then when we filter them out, they start to get back to normal, as you see on the graph. And we are starting to ask ourselves an important question. We are filtered, we are not accessible from the outside world. How is this traffic actually entering us? And we start to collect and analyze things, and we understood that actually these are real servers, probably compromised servers, which are actually in cloud operators or big hosting operators. And since the Giant network has a very large set of links to these cloud and operators, this is actually not internet traffic, but this is traffic coming from cloud operators into the research network and then hitting us hard. Things start to really get complicated because we see a constant 55 gig of attack passing our defenses, completely exhausting our current routers, and they start to run on 100% CPU. We are still collecting NetFlow data, and we see a large number of machines, more than 7,000 machines from cloud operators, and we start to see that all of them are actually in that amount of count. So we say it's time to finish this, to get the mouse games needs to end. We have to drop the tower and stop because our infrastructure can no longer actually handle daily attacks with this level. So we say, to battle stations, and we create a set of smart rules that will help us to completely block the whole attack. Attacks were pretty big, but after we designed some rules and we use a very cool thing we have in the Giant network, we actually have a very easy way to drop. What we actually do is we create, first, in order to stop student involvement, we say exams are back in the labs. From Monday, everyone is going back to the faculty. COVID is no longer a critical situation, and the situation allows us for students to go back to classrooms. And this will be easy because the classroom network is isolated and they can have exams without any problems. On the same time, on the firewall on demand system or in the Giant protection system, we create several smart rules for most of the problematic traffic. And when we actually do this, this is actually propagated to every router part of the Giant network on incoming packets. So we block all the traffic coming, including traffic coming from the cloud operators, and we see actually a win because suddenly traffic levels tend to drop completely on all of the protocols and networks. You can see here it's interesting for 11211 on the bottom, that's expected. This is memcache. But it's interesting UDP port 80, and this was discovered, and this is actually quick, but we don't have quick on the web server, so they were using this as a amplification attack vector. And since quick tends to fall back to classical HTTP, they were also doing a layer 7 protocol HTTPS extortion of sockets and connections. This is why we actually dropped because we are not going to support quick in this time, we actually dropped UDP port 18 and helped us to actually stop attacks on the load balancers, which are here mentioned in the 4 coming rules. At the end, we survived. We managed to collect a really large botnet data, and we shared this with important parties. With the help of GM security, we actually approach operators, and they approach the end users with the compromised servers. And most of those servers were cleaned. We got some feedback that most of those servers were actually then cleaned from the infection. How did we survive? Well, we use a magical recipe you probably heard of. It's called an IXP. We announce 1/24 only to IXP.mk, move all services there. Local access had unlimited access to services, plenty of bandwidth, and this means that students and professors can use all services. For the outside world, everything was not accessible. As a bonus from this, we got some interesting feedback from users that because of latency was super low, our traffic volumes were realistic. On the other side, we heard like, wow, what happened? Services are responding super fast. What did you do? Which servers did you reinstall? Did you get new equipment, etc., etc.? What we're going to do in the future, and we already started this, we definitely need to get more powerful routers for the faculty. We are going to get an upgrade on the Giant network, which will be 2 times 100, and we will continue to improve and get what we see total visibility. But since we will get more bandwidth, we will have risk of being attacked more with bigger traffic levels. This is why we are going to look into options for better BGP blackholing, because at least the Giant network supports this, but the local operators do not. We are also looking into on-site DDoS filter scrubbers for some high-profile targets like our own LMS, and we're going to do a bit more upstream capacity and diversity. We have a really big list of tools and products we are analyzing, both for the visibility and the protection, and we are trying to get what is best value for money. Unfortunately, we are a public university/faculty. Everything has to be done by a very complicated public procurement law. And on the other side, usually our budget for this is near zero or always zero. What we are in need, and which we hope that help will come from the community, because we need some help. We have a lot of our own fiber, black fiber, but we don't have the network transport system and the right technology to get higher speed than 10 gigs between our routers and our POPs and DC. And in the future, use this IXP.mk as a platform for local ISPs and other important players which are joined there to be a big DDoS protection system like this. I'm sure this will be possible to be used also for banks and other institutions if they are directly interconnected on the IXP fabric. And with this, I hope I'm on time. I'm finishing my presentation and am ready for questions.
Okay, do we have any questions from the audience for Vladislav? Okay. If there's no questions from the room, thank you very much for joining us remotely. We do like to extend welcome to our IXP friends from around the world, and it's always good to be able to even give the opportunity for them to present remotely. So thank you again, Vladislav, for your presentation. Very interesting. Thank you.
Thank you. It was a pleasure.